Okay, continuing our discussion of inverses. In the last video we looked at how to find the inverse of a function given as a map, and then how to find the inverse of a function given as a relation, or a set of ordered pairs. Here we have the graph f of x, that's the blue one, and we want to graph the inverse, f inverse, okay? And so we'll do one point at a time. Let's start with this point here, which is -3 comma -2. So -3, -2 is on the graph of f. Now the corresponding point on the graph of f inverse is -2, -3. So we just switch the x and y's. We switch the input with the output. So -3 comma -2, the new point is -2, -3, which is of course right here. So that point is -2, -3. Okay, now the next point that we have is -2, 0. And if I switch the inputs and outputs, I get 0, -2. So 0, -2 is right here. That's the point 0, -2. Then the next point is 0, 1. That's on the graph of f, so the point that's on the graph of f inverse is 1, 0, which is right here. And finally, the last point that we see, the end point is 2, 4, and so the point on the graph of f inverse is 4, 2, which is right here. And of course, joining these dots that we made in green, this one, and this one, that is the graph of y equals f inverse of x. That's the graph of f inverse. That's the answer for this question. Okay? Now, a very cool relationship between the original function and the inverse function is that the green function is basically a reflection of the blue function. It's like folding the blue function about the line y equals x. And so one way people do this is if you draw the line y equals x and then take each point and just draw a perpendicular line, then you can make your reflections. And of course these are just perpendicular lines. And not only perpendicular lines, but the perpendicular bisector, which means that this distance here is equal to this distance here. And this distance here is equal to this distance here. Okay? So there's a relationship between the original function. You can fold it over the line y equals x and it'll perfectly overlap. Let's look at one more example here. So again, we have the same question. We have the graph of the original function and we want to graph the inverse function. So again, I'll make a list here of all the points that we see on the graph of f from left to right. So -2, -3, -1, 0, 0, 3, and 3, 4. And then we'll take a look at the graph of f inverse. So the first point will switch -3, -2, 0, -1, 3, 0, and 4, 3. So we put these points on the graph, -3, comma -2, it's right here, 0, -1, 3, 0, and 4, 3. And then join these. And there you go. And again, just to check, let me see if I can graph the line y equals x. Oops, that's not a very nice graph. Let's try that one more time. There we go. So that's the graph of y equals x, and I think you can see that if you fold the blue and the green ones over one another, they will perfectly overlap. So this is how you find the graph of an inverse function. The next thing we want to talk about is equations. Okay. equation. So if I have the equation of a function, how do I find the inverse? Well, before we can do that, one thing I'd like to do is, if I tell you here are two functions, are they inverses of one another? Okay? So let's take a look at what that means. Two functions are inverses of one another if and only if their composition is the identity function. Y equals x. So in other words, if I have f and g are inverses, that'll happen if I compose f and g. F of g of x will be x, and if I compose the other way around, g of f at x will also equal x. So the input equals the output. That's the identity function. So let's check. Verify that f, let's see what f is. F of x equals 3x minus 5, and g, so g of x equals x plus 5 over 3 are in fact inverses. And the way we verify that they're inverses is we have to calculate f circle g of x. And we're going to do the calculations, and hopefully we're just going to get x. So let's do this. From the definition of composites, we write this as f of g of x, and then we're going to replace g of x by what it is. So that's going to be equal to f of, so let's put g of x in there, that whole big thing, x plus 5 over 3. That's my g of x. Now we're going to do the f. The f part does 3x minus 5. 3 times blank minus 5. So for that blank, we're going to put what? X plus 5 over 3. And then simplify this. Well, this simplifies this pretty easily. The 3's cancel because one is multiplied, one is divided. So we end up with x plus 5 minus 5, which is equal to x, which was our hope. So that's a good sign. Now, let's do the other way around. We still have to get x. G circle f of x. We're going to calculate this, and hopefully we're going to get x again. So we write this as g of f of x, which is g of, and then here instead of f of x, we're going to write down what the formula is for f of x. What is the formula? 3x minus 5. There it is. And then what does g do? G does x plus 5, so blank plus 5 divided by 3. Instead of the blank here, I have what? 3x minus 5. So this is basically 3x minus 5 plus 5 all over 3. Here, 5 cancels, and we end up with 3x over 3, and 3 cancels. And so the final answer is x. Okay. So bottom line, we've established for these two functions that we have f of g of x equals x and g of f of x equals x, and so our conclusion is, therefore, f and g are inverses. Okay, so if I give you two functions and I say verify their inverses, this is how you figure it out. You have to compose them in two different ways, in two different orders, and you're supposed to get x. In the next video, I will show you how to actually find the inverse formula. So in the next video, if I were to give you a function f of x, I'm going to show you how to find that other function, the inverse function, from algebra.